Computer science has been thought of as just programming. Although it's one of the undergrad majors that contains the most programming, doesn't mean it's only that. It encompasses many other areas, concentrations, and topics. Google can define the term computer science as the study of computers and computing along with their practical and theoretical applications. I think if I was asked this question years ago, I probably would have said building computers, or that I don't know. What someone can see or expect in an IT course is programming, networking, and physics. We'll go into detail a bit later. Here's what to expect in a computer science course, or what's most likely to come. Basically, it's an umbrella term which encompasses four major areas: theory, algorithms, programming languages, and architecture. For those who haven't been caught on yet, computer science is the study of how to manipulate, manage, transform, and encode data on a computer. Programming is learning how to program or code, obviously, but in its formal definition is a process of creating a set of instructions that tell a computer how to perform a task. In a class, you can expect to learn how to output a statement for your user to see, how to make your computer take data from the user, and how to give a variable a value. Additionally, you will learn arithmetic operations in an introductory class. Lastly, you will also learn syntax like the semicolon after every line. Not only these small codes that I have shown, you can learn a variety of topics that includes but are not limited to conditions, loops, and arrays. A computer network is a group of computers which are connected to each other for the purpose of sharing resources, and networking is using said computer network. The diagram at the top right is not a part of the computer network as it's not connected with wires, but if I connect them like at the bottom, it is, all because they can now send resources to each other. Some characteristics of a computer network include resource sharing, to be able to send resources, data, or information from one computer to another. Communication speed, so that high-speed communications can be made easier between computers on the same network. Backup, if your data has been lost or erased, you can get it back through a server since another system on the network should have it. Scalability, your network should be scalable because it would suck if you wouldn't be able to add on to it later when you need to. Reliability is that lost data can be found again. Software and hardware, if you download data onto your main server on a network, all the other computers will have it as well, and you won't need to download it to each computer separately. Security, provide security so permanent damage can't be done to your data. Examples, encryption. Some parts of a computer network are switches, routers, gateways, and ports. On the right, we have different types of networks ranging from PANs to WANs. PANs are personal area networks. It's a network you could use in your home by connecting your computer to printers, Wi-Fi, Bluetooth devices. It has become a network. A LAN is a local area network that can be used in office buildings. MANs are metropolitan area networks. Basically, as the name states, it can be used in metropolitan area, more commonly known as cities. It can also be defined as a combination of LANs. Last but not least, WANs can be defined as a connection that includes local and metropolitan area networks. There is no fixed range for this type of network. A Electricity is all around us. We use it every day when we turn on our lights, the fan, and the TV. But do we know what it really is? To understand it, you have to understand what an atom is. Everything is made up of atoms. Your pen, the device you're watching this on, and even you. Think about eraser dust. They're pretty small, right? But atoms are smaller. Much, much smaller. If you take an object and continue breaking it into smaller units, you will eventually be left with atoms. They are building blocks of everything. Just as matter is made up of atoms, atoms are made up of different particles too. Electrons, protons, and neutrons. Not all atoms have the same amount of electrons because electrons can move between atoms. Atoms, not atoms, like Adam and Eve. Electricity is the movement of electrons from one atom to another. The flow of electrons is called current, electrical current. Electrons can move through all materials, but some better than the others. If they are able to move quickly and easily in a material, then it's a conductor. Silver and gold are examples of such materials. The opposite of a conductor is an insulator, a material that doesn't let electrons move well and doesn't conduct electricity. Plastics and styrofoams are insulators. To use electric current to power things such as light bulbs, and you have to create a complete pathway. A pathway is called an electric circuit. Physics and programming both put math to use. Both of the subjects can be used to logic each other out. A career options for these subjects is a physics programmer. A physics programmer is someone who creates software based on the basis of collisions, crashes, and other things that move. They write codes based on the laws of physics. To be able to do this, one will need a high-level knowledge of both physics and programming. A person with good analytical skills and no hesitation to go through mind-bending problems is a great fit. Logic gates and how to simplify circuits that are made with logic gates. I've always wondered how computers worked, like how I typed up the script and it appeared on the screen for me to use later on. Logic gates are considered to be the building blocks in a digital circuit. They take in one or more input and send an output based on that input. So if you turn on the light switch in your room, it would give an output of turning on the light bulb that corresponds with said switch. And light operates on electricity. The connection between light and a light switch is a circuit. All characteristics that I mentioned on a computer network are the answer to question why we need networking and programming. Privacy is compromised. We've been told what to be careful with what we put on the internet, but now more than ever. A couple weeks ago, a random person joined one of the class calls at my school and became a disruption. With encryption, you can manage to secure your computer network and more. And like programming, it's most likely to be a few lines of code to get the job done. Here's what I want you to do. Picture a scientist, IT person, or engineer. Just imagine. Now, chances are that you probably pictured a man for these careers. Even though women take up about 50% of the population, only 30% of the people in STEM are women, and minorities even less. It's difficult to imagine something without even knowing that they existed. Research has shown that at age 15, girls have lost confidence in STEM subject. This is because of the barriers put in front of women from the beginning of times. These barriers have been placed by stereotypes and biases and fixed mindsets. Now this is where the video is going to be a bit delayed, but just stay tuned. You can go back and front to see the pictures of the people who I'm going to mention. What you need to do to engage more girls is to celebrate female role models. I'm sure almost half of the women don't know any major women role models. Women through time have seen little to no representation in quote-unquote a man's field. I mean, do you know who Katherine Johnson is? A mathematician whose calculations of the orbital mechanics as a NASA employee were critical for the success of the first US crewed spaceflight, yet you know Euclid for Euclidean geometry and math, and algebra, I mean? Do you know Sylvia Earle, a marine biologist who was famous among the first underwater explorers to make use of modern scuba tools, but you know who Charles Darwin is? Or do you know Rosalind Franklin, a chemist who established that the molecule existed in a helical conformation, but wasn't credited, rather a man was? Here's how to engage them more. Be an active mentor. From personal experience, when a mentor or a teacher actively includes me in a classroom, I feel more interested. Thirdly, foster confidence. Girls grow through life with a fixed mindset, thinking that criticism or not doing something right on the first try means failure, and that improvement is impossible. And lastly, that ability is inherited. But you should teach them that the struggle is part of learning, the ability is gained, and criticism is welcome, and improvement is very important. I'm almost done and it will go a little bit over, but the demand and supply of IT students. That sounds weird to say, but it's the truth. There's a large demand for students or adults with computer science or IT background. Sadly, most of the undergraduate schools look for students in underdeveloped countries with the ability to offer scholarships. While in Belize, the only high school that offers IT as a major is Belize High School, and out of the 60 students in the class of 2021, there are 16 IT students. With a surplus of in jobs, I think I can safely say that becoming an IT or computer science student is a good decision.